Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's DevOps webinar, Extending GitOps to the Enterprise, brought to you by Harness. We have a great webinar for you today, but before we get started, I need to go through some housekeeping announcements. Today's event is being recorded, so if you miss any part of the webinar, you will be able to watch it again. We will be sending out a link to access the webinar on demand, or you can visit devops.com/webinar, and it will be available for you as well. We are taking questions from the audience throughout the presentation. Use your webinar interface to submit questions into the Q&A section, and we will try to get to as many as possible. Finally, stick around until the end because we are doing a drawing for 4 $25 Amazon gift cards, so stay tuned to see if you're a winner. Joining me today is Srinivasa Gurbelli, founding engineer and chief architect at Harness, and Samarth Wadhwa, senior product manager at Harness. I'm now going to put myself on mute, turn off my camera, and let you begin.
Thank you, Julio. Good morning, everyone. I'm Samarth Wadhwa, and I'm one of the product managers here at Harness. Joining with me is Srinivasa Rao. We'll be your guides today. So we really want to get started and go over, one, what is GitOps, and also the rise of GitOps, what has really caused for everybody to move towards GitOps. That's what we're going to talk about. Then we'll briefly touch upon the GitOps 101, the whole idea being why exactly GitOps is becoming so famous. And next, we want to briefly touch upon the myths and facts. There are a lot of myths about GitOps, and we really want to talk about what are the myths, what are the facts, and how exactly GitOps, can help solve certain things. Next, the challenges with GitOps. A lot of people have seen different sets of challenges. We'll briefly cover what those challenges are and the enterprise approach to solve these challenges for GitOps. And now I'm just going to go into the rise of GitOps. A decade ago, if I were to start on Srinivasa's team, who is the architect, right? I'm coming in as an application developer, and then once I come in, Srinivas tells me, hey, Samarth, go and provision a particular dev environment and make sure you have your VM set up, you have your JBoss set up, and also using JFrog. Now, the other sets of environments that are being pre-provisioned is also being taken care of by my team, but there are so many people involved in order to do this. The first person involved is the systems engineer. They help me with what the setup should look like. They tell me what the VM configuration should be, and so on and so forth. Next, I have a networking engineer. My networking engineer is going to tell me what the load balancing rules are going to be, what different policies I need to apply. And last but not least, I have a middleware engineer. So all of these different things has been divided by different sets of people, and everybody owns these different entities. So I need to go to each and every engineer to make sure that I can get my VM provision, and also I can make sure that I'm up and running within a few minutes. But no, that is not the case, because it's going to take me about 2 to 3 weeks to get a new virtual machine. Next, a load balancer change is going to take anywhere between 2 to 4 weeks. And last but not least, to add a new app server node is going to take another week. Hence, I'm sitting over there twiddling my thumbs for almost about a month and a half because I'm trying to understand what exactly I need to do when I get the virtual machine set up and also make all these different changes. Now think about it this way. If I come on today in Srinivasa's team, what is this new setup going to look like, right? A new virtual machine can be up and running in 10 to 15 minutes. A load balancer change now takes 2 to 3 minutes, and a new app server node, 5 to 10 minutes in order to be up and running. So technically, if I join his team today, within the next 30 minutes, I should be able to get started, and I should be able to start writing my first pull request that I can submit for the application. Next, I'm going to briefly touch upon progressive versus declarative deployments, also known as push-based deployments and pull-based deployments. So thinking about progressive versus declarative, if you look from a progressive standpoint, these deployments are nothing but deployments that have a change being made to your manifest repository, and you are pushing a particular change. In this case, what happens is that you have a particular artifact that you are writing the code for, and then you make a push. And as soon as that push happens, you go ahead and you trigger either a workflow or a pipeline, and that goes ahead and deploys that particular change to your cluster or the infrastructure of your choice. Moving to the declarative side of deployments, it follows a pull-based model. What does this mean? It has the concept or the notion of a operator. With this operator coming into the picture, what it does is it looks at your current state of your application, which is running on a particular Kubernetes cluster, and it also looks at the states that is defined in Git. The whole idea is to continuously compare and contrast what exactly is changing on your Git repository and making sure that those changes get applied to your specific cluster. Now, that's an important thing, right? Because from a pull-based model, when you declare a particular change, that change gets propagated across all your different clusters, and it makes sure that the state of your application is pretty much in sync with the state of Git, making Git as your source of truth. Next, I'm going to talk about some common GitOps tools that we see in the market. If you think about it, we've seen all these different tools such as Argo, JenkinsX, GitLab, CodeFresh, and Flux. Now, the important thing to consider is that all these different tools and providers in the market today, they are solving some part of GitOps. But are they really solving all of GitOps? I think that's the question we really wanted to answer today as a part of this webinar, because when we look at it from an enterprise grade tool, we want to make sure that we solve for a completely different use case and also make sure that GitOps is able to solve the enterprise problem along with everything else. The good and the bad. Now, everything that comes in with something good and something bad. So obviously, even GitOps comes with the same thing. The first thing saying that, the good part of it is the source of truth is always Git, which is amazing, right? Because we know that if anything should change, if anything should have changed, we know that we need to go to Git, and that will remain as your source of truth. Next is drift detection. In order for anything to change from the current state of your cluster, and if anything is changing in Git, we have the ability to do drift detection, which means that a drift is detected, and we know what exactly has changed and how the reconciliation happens between Git and the cluster is all taken care of by GitOps. The bad. When it comes to a non-declarative infrastructure, that's where GitOps does not really play a vital role. Now, non-declarative infrastructure could be tools such as virtual machines. They need certain steps that you need to deploy, and then all of that happens in a non-declarative manner. Next is with regards to failures, audit trails, and role-based access control. GitOps does certain sets of role-based access control and audit trails, but everything at a cluster level. But is it really good at handling failures? I think that's always an open question, to be honest. Last but not least is the confidence building steps. Say you wanted to run some form of QA analysis or regression tests. For that, GitOps is not the best way to go because DevOps offers that capability where you can run a certain set of steps after your pipeline is running or as a part of your pipeline and make sure that everything is looking correct before you deploy it to certain other clusters or virtual machines. All right, moving on. I'm going to spend some time on GitOps 101. Real quick, we're going to talk about what is GitOps. Well, this was a term coined by vWorks in 2017. It was the concept that spoke about pretty much how an engineer was enacting a code change and Git was becoming your source of truth and how exactly that was being propagated across different cluster and infrastructure changes. So that exactly is GitOps, guys. The whole idea for doing GitOps from back in the day was to make sure that as changes get propagated, it goes to the end users then and there. And also we make sure that Git is always your source of truth because let's be honest, everybody, including all developers and DevOps engineers and SecOps, love to be in Git and want Git to be their source of truth. Next, we're going to briefly touch upon the GitOps principles. I know we've covered a part of this, but the entire system is described declaratively, which means that each and every entity that you perform in Git, think of it like a transaction, maybe a banking transaction as well, right? Everything that happens is a particular change that we do, and that gets propagated to your cluster. Next, the canonical desired system state is versioned. Say Srinivas goes and makes a change, and maybe we have another team member. He also goes and makes a change, and I go make a change. Everything will be versioned within Git. So that way we exactly know what has changed and how exactly we can handle these changes should something break, and how do we go back to the previous commit from Git. Next is the approved changes that can be automatically applied to the system. What does this mean? It basically means that as soon as you approve a particular change, upon drift detection, you will be alerted that, hey, the current state of your system has diverged or has changed. And now what exactly happens is that as soon as the user approves this, they can go ahead and they can apply that change to your clusters. And last but not least is the software agents to ensure correctness and alert on divergence. It is nothing but the drift detection capability where when something does change, we make sure that we are alerted on that divergence, and then we can decide if we'd like to apply that change or not. With this, I'm going to pause for a brief second. I'm going to turn it over to Srinivas to continue with the myths and facts of GitOps.
Hi, good morning, good evening to everybody. Thank you very much, Samar. Right. So if you have any questions right now, and feel free to put it in a chart. Now, I would like to let us go over myths and facts. So, one of the myth is GitHub is only for kids. Is it true? You can answer it in the chart. Well, the answer is no, because it does not matter if the cluster runs in a KX or not. All GitHub cares about is having an operator, and the source as a Git, and the destination could be any infrastructures, VMs, or for a moment, it could be any other services. Now, the second fact is is GitHub's only applies to cluster changes, right? As mentioned before, GitHub is not just for K8s. As we see here, there is an engine, GitHub engine, with the predefined rules and configurations responsible for monitoring the Git configurations and observing the current state of the cluster to take actions. Also, in this case, we have a cluster state, which can also happen to be a VM state or any other services, right? Now, okay, GitOps is centralized strategy. People assume that there is a centralized strategy like DevOps, where we have a template that can be reused across different environments. In the case of GitOps, that is not true, because there is a one-to-one mapping between the cluster and Git repositories. So it does not follow the paradigm of centralized strategy, which means users will have to maintain separate repositories for different environments, which is good. However, it comes with an overhead of maintenance, consistency, visibility. We are going to talk about that in the coming slides. Now, DevOps versus GitOps, right? There is an assumption that GitOps is subset of DevOps, obviously, which is not true. The principle for DevOps is to break silo between dev and operation, versus for GitOps is to have intelligent automated ops. Now we know that what is driving principle in the case of CI/CD. DevOps follows push-based model. GitOps follows pull-based model. In case of deployment, DevOps covers imperative approach. GitOps is like declarative. And when it comes to the monitoring, DevOps provides monitoring at all layers. GitOps mainly concentrated on monitoring the status of the desired versus current using operators. We are going to talk about more in the coming slides. So, okay, so far we learned about the myths. Let's talk about the facts. One of the facts is GitOps is great as a continuous delivery solution, where each commit results in a release candidate ready to be pushed in a production. Continuous deployments, on the other hand, is the full end-to-end journey of a commit straight into the production without any manual intervention. What does that mean is whenever the developer checks in the code, he can go and happily sleep. Everything will be taken care by the GitHub, by the continuous deployment process, where he doesn't need to worry about where is the PR, whether the PR is approved or not, and whether it is stuck in with someone, or whether it's stuck in with the security team and everything, right? So GitOps requires a little bit human interaction. It requires human intervention. GitOps, why? GitOps powered by the pull request on a repository that contains our manifests. And in most cases, human needs to look at and approve these pull requests. This means that practicing GitOps involves at least some manual steps for handling these pull requests. In theory, one could practice both GitOps and the continuous deployment while still adopting the GitOps by fully automating the pull request. But that is very difficult and there are challenges around it. The another fact is GitOps does not address promotion of release between environments. As I mentioned earlier, GitOps is one-to-one mapping between cluster and the Git repo. What does that mean is, if you want your service to be propagated across QA and staging and the production, you need to have at least three applications which will be mapping to your Git repository. It could be one Git repository, or it could be multiple Git repositories, or the single repository is differentiated by the branches, whatever it is. But you need to have three Git repositories to map it to the three environments. So that is a fact. What we're going to lose, we are going to cover on that, and how to address this problem, we are going to cover on that. The another fact is that auditing is a problematic despite having all information in Git. So one could argue that, hey, the Git is very good in version history and the Git history. Is that good enough for enterprise auditing? May not be, because you always have some reviewer or approver as privileged to do post push. Once you do the post push, you will lose all the history. So is it like enterprise is going to like it? Yes, but we need to have more than that. The auditing should be preserved, and there should be a visibility across days, and we need to do some analytics on the auditics and follow some security principles and all in that. Now another fact is GitOps covers only subset of the software cycle. So GitOps tools are sometimes marketed as the one size fits all solution that will solve your all release problems, and this is simply not true. First of all, GitOps requires that your deployment artifacts are already there. That means in a whole DevOps cycle, some part like compiling the code, running unit and integration tests, security scan, and status analysis, this all are outside of GitOps. Okay, now, so we talked about the myths and facts, and now let's go over some of the common challenges that everyone faces today with the GitOps. The first challenge will be the governance. So what do you mean by what is governance, right? As you know, GitOps is dependent on a pure PR process, PR approval-based model. The onus is on the PR approval. You should be well aware of what is going on between securities, what is going on between the other teams, and whether the developer is whatever he made changes, whether it is right. Like for example, developer thinks that we can support the replicas 5, and he might have changed the replicas to 3 to 5, but it will be simple change. But we don't know the fact, like whether that is a valid change, or whether the company allows the policies to be changed to 3 to 5. This all, it is not easy with the simple PR approval process, right? But enterprise have been looking for ways to control what end users can do on the cluster, and ways to ensure that clusters are in compliance with company policies. These policies may be there to meet governance and legal requirements, or to enforce best practices and organizational conventions. So auditability. As I mentioned earlier, default GitOps process is not fully auditable. The key reason is post push. Post push essentially allows to remove any unwanted blocks of commits from Git history on the central repository. We are going to talk about that, how we are going to solve this auditability problem in an enterprise world. The most important thing is like business approvals. Typical approval model used in GitOps is via pull requests. Developers make changes, create a PR, then approver may accept such PR, which would be recorded, and change would be deployed. Such a PR-based approval model is based on a premises that everybody already uses a Git and knows what PR is. All this is great to the point where we need business approvals in the mix. Business approvals may very well not know Git, not know what PR is, and not understand what is happening. So if we have a business approvals, we have to go back and have to build a process over GitOps process, which ultimately increases the lead times, and there is a manual intervention, and all these things will come into picture. Okay, now we talked about the myths, we talked about the facts, and Samarth explained about what is a journey like a decade ago. Now, we talked about there are common challenges. Now, like, is it GitHub solved all the problems, or this GitHub solved all these problems? No. Now, let's talk about like how to do this at an enterprise level, right? So, governance. So, like, let's say we talked about what are the challenges with the governance. Now, let's see how to address this governance. There are many reasons why developers and platform engineers integrate policy as a code into their in the current GitOps process. So nowadays, like this ops suffix is coming to picture. You have the config as code and like policy as code, GitOps, which primarily covers the deployments, and we are going to talk about AI ops, all this, right? But when it comes to the governance, is the governance like a policy as code should be integrated as part of the GitOps process, right? So such that, let's say if you're creating a PR which happens to change something, at the same time, this PR might require to make some changes to your SecOps, your security policies, right? And for example, you need to block some port or you need to open another port. So now, let's say if you think GitOps and this policy as code to different silos, then as a developer, I create the PR for my manifest changes, and now I would be waiting on the other security team to do the changes in the policy as code, and then it is no more like continuous deployment, right? It is no more like continuous delivery. So what if you integrate the policy as code along with the GitOps? So for example, developer may have no reason to know when deploying a load balance onto Kubernetes in AWS is or not compliant, right? Policy as code solves this problem automatically. That means as a PR checks, we run the policy as code checks. If everything is good, the PR will be merged, and the new changes will be deployed into the cluster, right? The ability to run policies during GitOps deployments and adhering to the policies as part of the deployment, and upon any violations, alert, audit, notify, and auto rollback the changes from the Git to the previous successful compliant state so that Git remains in sync with the cluster. Okay, let's talk about GitOps plus AIOps. So there is a notion that once GitOps is completed, which is good, the source of the truth is Git, and the changes are deployed into the cluster, and we are happy, right? But the world is not like that. There are many unknown reasons or unforeseen activities will come. Your application behaves or your infrastructure behaves normal during the normal load, but all of a sudden it behaves very different during peak hours, or there is an hack, right? Or there is a compromise happened. Now, so as part of GitOps, we can see the manifest change or infrastructure or artifact change. But post-deployment, GitOps operator can instantly understand the changes in the service health and what caused those changes, and automate the process of investigating those changes using AIOps, and apply the machine learning, apply canary analysis, and do that canary analysis like the previous manifest changes and the previous build behave like this, and that is the baseline. Now there is a newer version came, and with the newer SecOps changes, newer manifest changes, the new artifact changes, then we should see how it is behaving from the previous build. And as a you could write a policies or rules to detect is there any violation, right? Is there anomalies? And what is the threshold? And let's say then GitHub's process should automatically automate that process while deploying. Let's say I would take one example. We usually do the canary deployment. So if we do the canary rollouts, then once you do the primary deployment, we wanted to make sure that these all new nodes are good enough to uh, uh, solve to like adhere the all the policies, and they have behaved very properly in everywhere, right? Now what you could do is we should run the analysis like AOps against those primary nodes and get the feedback loop and see if there is any anomaly. Then we should automatically roll back. This automatic rollback should involve from like end to towards the still the developer. What does it mean is you have to revert to the commit, the reverting the previous commit in and merge that reverted commit so that the newer version will be applied to the in order to like keep it live and restore to the previous state. Okay, that's all. Like we need to integrate in the GitOps and the AOps. Now, which is good. We talked about GitOps. Like GitOps solves the drift. Drift is the drift is nothing but like as Samarth told, it is what is the difference? What is the in the cluster and what is in the Git, and then you can view the drift, and you can you can view the drift. You can see whether the changes are good or not in the PR, right? But let's say if but that is not enough. Enterprise customers would like to be alerted whenever there is a drift in their repository. And based on that, customer can choose to approve or reject the drift. If rejected, the merged PR should be reverted to the previous state to ensure that Git is in sync with the desired state of the cluster, right? So we have to build automatic like drift detection, alert mechanism, notify in a Slack, notify in a emails, or create a Jira, and automatically create a Jira and a ticket. The ticket will go for an approval. When automatic approval happens, proceed with the PR merge, right? So
Yeah, I think we can open it up for questions now. Want to just make sure that, if we do have any questions, we'd be happy to take those now.
Yes, we do have questions, but one thing I want to remind everybody is that you can submit questions by going to the Q&A tab next to chat and submitting your questions that way. Okay, so one question we have here is, do you have any suggestions on a GitOps tool for infrastructure? I've been using Argo CD on Kubernetes /OpenShift, but I would like to know if there is any similar GitOps solution for, I believe that's IAC, using Terraform, for example.
Yeah, so that is true. There are like GitHub tools available like Argo CD and on the Kubernetes and OpenShift. There are some tools like to do the infrastructure as code, but that is also not like fully compliant to the enterprise. Like for example, it is based on the Terraform and everything. But as we speak, you might be familiar with Ornez. Ornez is like customer, like it's not a open source, but it is one of the best standard in the industry. They are like working on like, and as you speak, I'm also part of Ornez. We are working on the IAS tool, like infrastructure as code. It's completely agnostic to either it is a Terraform or anything like any other provisioners. So we can get back to you, but I don't have like any proper solution ready. Anyone is solving that IAS properly as of now.
Okay. Well, right now we don't have any other questions, but we'll give it a minute just to give people time to submit any. Oh, and somebody wants to know, how do you spell the name of the solution you mentioned?
Honest.
Also, is GitOps only for container based?
No, that's what we are saying is it's GitOps is mainly for Kubernetes and it is saying like container, but in reality it is not true. So GitOps means it can be like you can use against the infrastructures or any VMs. For a moment, like for example, we could extend the GitOps process to intercommunicate between the two different services also. For example, in a middleware and everywhere, if you want to, if you have a service and you are producing some of the output, and that should be consumed by other services, you can automate through this Git process. So the answer is not. It can be for anything.
Yeah, and I also feel I just want to add something here real quick, guys. For GitOps only for container based, right? That seems to be like a myth for sure. A lot of times folks do get confused that everything happens to be anything GitOps related happens to be only for containers, but the answer is that it is not. As Srinivas mentioned, it could also be a virtual machine or any other service for that matter, where GitOps can be extended. It happens to be that Git should remain as a source of truth, but also there are different ways to solve it. So that's something we want to be cognizant about, and we want to make sure that that's how we can do it. I think it says it would be good to have an enterprise-grade tool for comprehensive GitOps on virtual machines and Kubernetes. How do you suggest using Wavefront Ignite? It seems nice, but it's still in alpha. I feel like we will have to do a little bit more deep dive on what the tool does. But it seems like if these guys are doing a form of comprehensive GitOps, right, it might be similar to being able to see what your state of Git is and applying that on virtual machines and on Kubernetes clusters. But also it comes down to tying the enterprise grade features, right? You want to make sure that they can solve for not just the drift detection, but also the ability to do the entire approval based mechanism, right? You want to make sure that you have your role-based access control. You want to make sure the audit trails that give you the capability to go and see who did what, when, and where. Those are the different enterprise-grade features you want to look for while deciding a tool that you want to use in order to do GitOps. How do you incorporate continuous testing as part of GitOps? Is there any specific tool for testing infra container-based code? Srinivas, you want to take this one?
How do you incorporate continuous test? Yeah, so that's what like this when we are saying that extending enterprise GitOps to the enterprise, as of now there is no open source solution available to do this continuous testing, but there are some vendors like Cycle CI and everything they do as part of pipeline process. What Awareness trying to do is they are going to come up with a open source. They're going to come up with this like this solution through a pipeline. So how to address this solution is like you have a unified pipeline where you do the CI, the build, and then after the CI stage, there is another stage called or another step called like test intelligence, right? Or so testing. You keep testing that in that stage, and if you make sure if you are sure that these are the test results are good, then you can have a GitHub stage where that stage does is it automatically creates the PRs against your targeted environments. Then you can attach some of the policies to the stage if those all policies are met, it can be automatically approved. That's where you have to extend the GitOps. That's the reason I was mentioning in my previous talk also. GitOps is the continuous delivery. In order to achieve the continuous deployment or continuous testing, we have to extend the GitOps and introduce the concept of the pipeline where this all can be automated.
All right, I think another question from Flux looks like implementing Kubernetes dev environment, but how can we extend to prod with more security tightened with approvals?
So yes, that is one of the challenges in the vanilla GitOps. Like you make changes to the dev environment, but how do you, in order to make the same similar changes to production environment, you have to do the same manual process. Some part, if you see Argo CD, it does solve a little bit by introducing the application set controller, where that application set controller nothing but like where you can automate this creating this applications in the prod by reading another repository which contains the configurations, right? But there should be more than that. What should be more than that? There should be, obviously that's not there. That's what I was talking. There should be a more than that. The environment propagation pipeline should be there. What does that mean is you make changes to the dev and you need to have a verification step where you verify all those changes, and with approvals, then you file all those approvals and everything in the staging environment. Then once you approve it, it should create a PR against your production environment. Then after that, GitHub should take care of it. I hope, does that answer your question?
Okay, excellent. Still have plenty of time for questions if anyone has anything, but I did want to remind everybody that today's webinar has been recorded. So if you missed any or all of the webinar, you will be able to watch it again. We will be sending an email with a link to access the webinar on demand. It will also be available on devops.com. So look in the on-demand section and in the webinar page, and it should be there. Also, I do want to make mention that the handouts, the slide deck has been uploaded. So if you'd like to download that, you can go to the handouts page and download it for yourself. And while we have a little bit of time left for questions, I'll go ahead and read the four Amazon gift card winners. Our first winner today is Onofrio L. So congratulations. Our second winner is Peter T. Congratulations, Peter. Our third winner is Pedro A. Congratulations. And our final winner is Deepak R. So congratulations to our winners. We'll be reaching out to you via email with an instruction for claiming your Amazon gift card. So please check your inbox. And if you don't see anything there, check your spam folder. And still not seeing any new questions. So it looks like you all were very thorough with your presentation, which is good to see. All right. All right then. Well, going once for questions, going twice. Okay, well, thank you very much to Srinivasa and Samarth for an excellent presentation. It was really nice listening to you speak. And thank you. Thanks again for the audience for joining us and for your questions. Oh, looks like we might. Where can we find the presentation? The presentation will be in the handouts. It's right. It's on the right next to Q&A. And from there, you can download it. If not, it will be available to you in the same email with the instructions to watch the on-demand. So with that, again, thanks again to our speakers for an excellent webinar, and thanks again for the audience. This is Julio Godinez signing off until next time. Be well. Thank you.
Thank you all.